So today I thought it would be a nice idea to go through this encyclopedia. I really enjoy watching ASMR videos where artists go through these types of non-fiction books or maps and have a look at some really nice illustrations, as well as learning some interesting facts. I'm someone that loves non-fiction, I particularly love science, and I thought this book was interesting, but also did have some nice pictures in, so thought it would be a good one to show you all. So without any further ado, we'll begin. So DK Knowledge Encyclopedia. So obviously I won't read through the whole book. What I'll do is just read some odd sections and we'll look through, so we get some nice page turning sounds and some look at some of the good illustrations. So starting with the contents, we can see that this book goes through the universe, looks at space exploration, the Earth, and the subsections in this part include planet Earth, tectonic Earth, Earth's resources, the weather shaping the land, Earth's oceans, and in the nature section we have how life began, the living world, invertebrates, vertebrates, survival secrets. This would be my favourite section, human body, and within that we've got body basics, fueling the body, in control, and the life cycle. In the science section we have matter, forces, energy, electronics, and I think this is the final one. The history section, we have the ancient world, the medieval world, the age of discovery, the modern world, and then in the back we have the reference, the glossary, the index, and the acknowledgements. I think we'll start off with the space section. Like I said, I probably won't go through all of the sections. We'll just look at little parts. I do like the way this book is laid out. Okay, this is the universe. The universe is the whole of existence, all of space, matter, energy, and time. The universe is so vast as to be unimaginable, but we do know that it is steadily expanding following its beginning 13.8 billion years ago in an explosive event called the Big Bang. And this shows the scale of space. The Earth and the Moon, the solar system, stellar neighbourhood, Milky Way galaxy, a local group of galaxies, supercluster, the universe. in this vast dark void are all sorts of different objects, which astronomers call celestial bodies. They range from grains of dust to planets, stars and galaxies. Our solar system includes a star, the Sun, and a large family of planets and moons that formed from the same cloud of gas that gave birth to the Sun. In recent years, planets have been seen around thousands of other stars, showing that our solar system may be one of billions in our galaxy. I do find space an absolutely fascinating subject, and I don't know that much about it, to be honest. I'd like to learn more, so I probably will spend some time myself reading this in more detail. Okay, so what's the matter? The elements hydrogen and helium make up 98% of the matter we can see in the universe, but there doesn't seem to be enough matter to account for the way stars and galaxies are pulled by gravity. As a result, astronomers think galaxies contain dark matter, which we cannot see. There is also an unknown force making the universe expand, known as dark energy. You can see here, makeup of the universe. We've got 68% dark energy, 27% dark matter, 5% matter, and within that 75% hydrogen, 23% helium and 2% other elements. I won't read through all of this, otherwise I'll be here for a long time. But I do find this part's quite fascinating. So here we've got the universe began as something called a singularity, a point of zero size but infinite density. So this is the universe began, number one. Number two, energy turns into particles. Actually, the universe began as something called a singularity, a point of zero size but infinite density. Number one, the universe appears out of nowhere. At the start, the universe consists purely of energy and is infinitely dense and unimaginably hot. 10 billion trillion degrees Celsius, which is 18 billion trillion Fahrenheit. Very hot. Within a tiny fraction of a second, the universe balloons in size from trillions of times. Then we have, within a tiny fraction of a second, the universe balloons in size from trillions of times smaller than an atom to the size of a city. The rate of expansion then slows. The intense energy of the newborn universe creates matter. At first, the matter is a superparticles and antiparticles. These crash into and cancel each other out, turning back into energy. But some of the matter is left over. This will eventually turn into atoms and later stars and galaxies. I won't read through all of it, but I do think it's really nicely laid out. So this part is about the galaxies. We'll just read a little bit about the Milky Way. If you could look down on the Milky Way galaxy from above, the view would be like flying over a glittering city at night. Most of the galaxy's 200 billion stars are in the centre bulge. Curving around this are two vast spiral arms and several smaller This is interesting. We've got galaxy shapes. Astronomers classify galaxies into just a few main types depending on the shape we observe from Earth. Got spiral, barred spiral, elliptical, irregular. And this is showing the star birth. Interstellar cloud, fragments form, and the protostar forms, spinning disk, a star is born, planets form. And in this section it shows the star death. All stars eventually run out of fuel and die. Most fade away quietly, but the most massive stars self-destruct in a huge explosion that can outshine an entire galaxy. This is the Sun. The Sun is a nearly perfect sphere of hot, glowing gas. Its source of power lies buried deep in the centre core, where a nuclear furnace rages non-stop, turning matter into pure heat and light. Here's the core. Inside the hot, dense core, the process of nuclear fusion releases energy. Every second, more than 600 million tons of hydrogen are fused into the helium in the core. Core. Inside the hot, dense core, the process of nuclear fusion releases energy. Every second, more than 600 million tons of hydrogen are fused into helium in the core. Here's some Sun statistics. Diameter 1,393,684 kilometres, which is 865,774 miles. Distance from Earth 150 kilometres, which is 93 million miles. The solar system. The forces of gravity generated by the Sun's vast mass keeps a family of planets and other bodies trapped in the orbit around it. Together, the Sun and all their bodies make up our solar system. We got the Sun, Mercury, Venus, Mars, Earth, Saturn, Jupiter, Uranus, Neptune. Actually, sorry, I read that wrong because it goes Mercury, and then it's Earth, and then here it's Mars. Yeah, the orbital distance. Sun, Mercury, Venus, Earth, Mars, and they're all within 500 million kilometres to the Sun. Jupiter is within the surface is a different story. It's quite interesting. I'll read this a little bit. The inner planets all formed from the same material about 4.6 billion years ago. All are a mix of rock and metal, with interiors that are roughly divided into layers. The heavier metals are concentrated towards the centre, while the lighter rock is on the top. Each of these planets was bombarded by asteroids and comets early in the solar system's history. Mercury's heavily cratered face still bears the scars of the early bombardment, but the surfaces of the other three worlds have changed over time. Oh yeah, there's Mercury. Brightest craters are the youngest. I do think Earth looks the prettiest, but maybe I'm biased. It just looks lovely, doesn't it, with all the water, the land, the clouds. These are more rocky, obviously. Okay, let's talk a bit about Earth then. So, living world. Third out from the Sun, Earth is the largest of the inner planets. It's the only planet with liquid water flowing freely on the surface, and it's the only planet in the universe known to sustain life. Earth's surface consists of vast oceans, rocky continents, and two polar ice caps, all supported by a thin rocky crust. The crust is broken into 7 huge segments and many smaller ones. Called tectonic plates, these giant slabs of rock creep slowly over Earth's surface, pushed by churning movements in the softer, hot rock that fills most of Earth's interior. As tectonic plates move, they bump into each other and grind past one another, generating immense forces that thrust up mountain ranges, unleash volcanic eruptions, and trigger earthquakes. These powerful forces continually change Earth's appearance, as do the actions of wind and water, and the planet's 7.6 billion humans inhabitants. I mean, that might have gone up by now. I don't know how old this book is. Let's have a look. So it's published in 2018. It was first published in 2013, but then it was redone in 2018. So yeah, it's not that long ago, but I'm sure over the years things have changed. Okay, I could stay in the space section for a long time, but I think we might just have a look at maybe another section, and then I can come back and do another video potentially, and go through some more. Oh, we'll just have a quick look at the moon. I like the moon. Who doesn't? Okay, the moon is Earth's closest neighbour in space and looms larger than any other object in the night sky. Its cratered surface may be cold and lifeless, but deep inside the moon is a gigantic ball of white-hot iron. Showing the inner core. Okay, the living in space section is something I find quite interesting, because obviously it comes back to like how the body copes in these extreme environments, which I just think, yeah, it's a really interesting topic. So astronauts must adapt to a zero gravity environment when living in space. Although floating weightlessly can be fun, it can also cause medical problems. Space stations are cramped places with few luxuries. Astronauts eat ready-made meals that are either freeze-dried or served in pouches. All water is recycled, including the water vapour from human breath. Astronauts clean themselves with special shampoos and soap that doesn't need water, and they use space toilets that suck away waste rather than flushing it. So, the brain and balance. atmosphere. So, the atmosphere of the Earth is made up of several different gases: 0.9% argon, 0.1% of others. The others includes carbon dioxide, which was once abundant but is now incorporated into materials such as limestone rock, 78% nitrogen, and then 21% oxygen. Okay, so inside our planet, Earth's interior has layers. Scientists discovered this by studying the paths by which earthquake waves pass through the planet. Again, earthquakes can cause such devastation, and I'm sure we're all aware of some of the most famous ones that have happened. It's very sad to see the consequences of them. Okay, so the oceans, Earth's surface and atmosphere contain the equivalent of 1.39 billion kilometres of water. There are regions of deep ocean as well as shallow seas that cover areas around edges of continents. These are called continental shelves. Earth's surface has not always been as dominated by liquid water. In the past, during ice ages, when the polar ice caps were much thicker and more extensive, so much water became locked up in them that sea level was at least 120 metres lower than it is today, exposing the continental shelves as dry land. This brings back geography GCSE many years ago. So, continental crust, oceanic crust, mantle and core. I remember having to learn all of these layers. What's in a layer? Earth's crust and mantle are mostly made of minerals called silicates, which are a combination of silicon dioxide and metal oxides. The mantle is rich in magnesium-containing silicates, whereas the two different types of crust have less magnesium and more aluminium and calcium. The core is dominated by metallic iron. No part of it has ever been brought to the surface, but its composition has been worked out by scientific methods such as studying earthquake waves. I do apologise if I pronounce anything. Oh, this is some fun facts. 335 million years ago, Earth's continents began to join together, forming an enormous supercontinent known as Pangaea. Continental drift. This again is fascinating to think like where it all started and like what happened to produce today. So we got the supercontinent. Pangaea has begun to break into two main land masses. India has escaped from the southern landmass and is slowly moving towards Asia. South America has split from Africa, while in the north, North America is splitting from Europe. And today, Australia is separated from Antarctica, and India has collided with Asia, forming the Himalayas. This is incredible, isn't it? The Earth's surface. Inside Earth, we can't explore much of Earth. Our deepest minds only travel about 3.9 kilometres, which is 2.4 miles, into the crust. However, there are scientific ways to find out what is inside. This is what geologists do. They study rocks from all depths within Earth's crust, because collisions between continents push up rock that used to be below the surface, forming mountains. In some areas, collisions have even revealed vast swathes of the mantle. The Earth's atmosphere is made up of gases which are bound to the planet by gravity. There is no clear boundary to the outer edge of the atmosphere. It just fades into space. Outer space is generally thought to begin about 100 kilometres above the surface. gaseous atmosphere, surface water, and whether the living organisms can survive in. Almost every part of our planet is occupied by some form of life, from the deepest oceans to the highest mountains. However, the different environments and climates across the world affect how many and what type of species live in each place. Tropical regions are teeming with life, while only extreme survivors can live in polar wastes and deserts. And here it talks about what makes a climate. So, a climate is an average weather pattern that occurs in a set area over many years. The climate experienced at a certain location is influenced by its distance from the equator, elevation above sea level, the amount of sunlight it gets, and how the conditions and circulation patterns in the nearby ocean and atmosphere affect it. So it explains that places near the equator generally have higher average temperature and more diverse ecosystems. Rainfall atmospheric circulation creates zones of high and low rainfall around Earth. Some areas get much more rain than others. So I live in England in the UK, and I feel like we get a lot of rain. I know compared to other countries it rains more, but me and my husband went to Norway last year, and it usually rains quite a lot there, but we were really lucky we didn't have much rain. But when we did visit Ireland, we went to Kerry, and it rained so much, but I suppose that's why it's so beautiful. That's the thing, the places with high rainfall tend to have lovely greenery, don't they? It tends to look beautiful. Okay, I think I'm going to leave it there, because it's getting to that time where I think people will start making noises outside. So I'll carry on in another video with the rest of the book. I did think I'd get through more of this than I have, but I found it really interesting. I hope you all have enjoyed learning about some of the things we've discussed today, or if not, just enjoyed relaxing to it. I really do like these types of videos, so that's why I thought it would be nice if I made one myself. Just before I go, I just want to say a massive thank you to everybody who has liked or subscribed